So in the same model we have to study regarding with an operational amplifiers. So in this an operational amplifier, ideal characteristics of an op amp and practical op amp. Practical op amp circuit, inverting and non-inverting amplifier, voltage followers, summer, subtractor, integrator and differentiator. So in this operational amplifier, first of all we have to know and what is an op amp. So 741 IC, which is an 8-bit pack, which is known as be used as an inverting, non-inverting and voltage follower. So for this we have to know regarding with the, so you have to know operational amplifier parameters first of all. So that is open loop voltage gain. Open loop voltage gain is an operational amplifier. It is defined as the ratio of output voltage to input voltage measured with no feedback amplifiers. In practice, this value is this value will be very high, totally, that is greater than 100,000, but it will be considered as a device to another. So open loop voltage gain may thus be through often the integral voltage gain of the device, that is output divided by input. So gain of an amplifier always it will be expressed in a decibels, that is dB, that will be 20 log V out by V in. So most operational amplifiers has open loop voltage gain as 90 dB as well as more. So closed loop voltage gain. So what is this closed loop voltage gain? So closed loop voltage gain is nothing but a voltage gain of an operational amplifier is defined as the ratio of output voltage to the input voltage measured with a small proportion of the output fed back to the input, which is known as a feedback amplifier. The effect of providing a negative feedback is to reduce the loop voltage gain to a value that the both predictable. So practical closed loop voltage gain ranges from 1 to several thousand, but not that high value of the voltage gain may or bandwidth. So these are the parameters what you have to know, that is with respect to the voltage gain. So we will study one a small problems, that is they will give for the 4th marks problem. An operational amplifier operating with a negative feedback produces an output voltage of 2 volts when supplied with an input of 400 microvolts. Determine the value of closed loop voltage gain. So AV is equal to V out by V in. Thus AV equals 2 by 400 into 10 raised to minus 6. 2 into 10 raised to 6 by 400 equals 5000. Expressed in decibels rather than as a ratio. This is a 20 log 10, that which will be known as an substituting 74 dB you will get. So for 4 marks they'll ask to find out the determine the closed loop voltage gain. So if you come for an ideal characteristics of an op amp, so you have to know that is an offset voltage, input voltage, a full power bandwidth as well as slew rate. So if you come for an ideal characteristics, input resistance or the input impedance, which will be the ratio of input voltage to the input current expressed as ohm. So it is often and assume that input of an op amp is purely resistive, so it will be very high. So it should be an infinity, no current flows through the op amp. And output resistance, which will be here 0, and R in will be the V in by I in. So output resistance V out by V I in, V by I as an Ohm's law. So output impedance as an output resistance should be an infinity. Input offset voltage. So we know that input offset voltage typically it should be 1 millivolts to 15 millivolts. So that is, what is the input offset voltage? The voltage that must be applied differentially to the operational amplifier input in order to make the output voltage exactly 0 is known as the input offset voltage. Input offset voltage may be minimized by applying a relatively large amount of negative feedback or by using the offset null faculty provided by the number of operational devices. And one more parameter is known as a bandwidth. So bandwidth should be very high, which will be infinity, which ranges from 10 kilohertz to 1 megahertz for the same high speed devices. So full power bandwidth of an operational amplifier is equivalent to the frequency at which the maximum a peak output voltage swings. And one more parameter which is known as slew rate. Slew rate is nothing but rate of change of output voltage with respect to time. Slew rate should be an infinity. So this also which change of voltage with respect to time should not be exceeded. So the typical values. So operational amplifier characteristics, if you come, it is characteristics of an ideal op amp. Open loop gain should be high. Ideally, the input resistance should be very high. Ideally, it should be infinity. Output resistance should be very low, that is will be 0. Full power bandwidth should be as wide as possible, so it should be infinity. And slew rate should be as long as possible, and input offset should be as small as possible. So these are the ideal characteristics of an op amp. For 8 to 10 marks, they'll has the an ideal characteristics of an op amp. So ideal characteristics of an op amp is open loop gain should be high. That is, input impedance should be high, output impedance should be 0, bandwidth should be infinity, slew rate should be infinity, common mode rejection ratio should be infinity, and also the frequency power bandwidth will be high, offset should be as small as possible. So this is the typical value of an ideal op amp. So they will ask, so you can see the parameters ideal as well as real. So it will be input resistance will be in mega ohm, output resistance will be in ohm. So bandwidth will be 2 megahertz. Slew rate will be 10 volts per microsecond. Input offset will be 0 or less than 5 millivolts. So operational amplifier configuration. Three basic configuration for operational voltage amplifier together with voltage gains are shown in figure. Supply rails have been omitted from this diagram for a button assembles to be symmetrical about 0. All the amplifier circuit designs previously have used directly coupling and thus have frequency response characteristics that extended to DC. This, of course, is undesirable for many applications, particularly when a wanted AC signal may be on an unwanted DC voltage level. So inverting amplifier with feedback. So figure shows the inverting amplifier, non-inverting amplifier. You can see here it has got two input, inverting amplifier that is minus and non-inverting amplifier as positive. So if it works as an inverting amplifier, you have to give the input to the inverting circuit and non-inverting terminal will be grounded. And feedback resistance RF is used. So the gain of an amplifier can be varied with respect to the feedback resistance. And figures B represent non-inverting amplifier. So non-inverting amplifier, you can see that is Rin and RF at output as well as input. So differential amplifier, that is subtractor or adder, it can be used. So if you connect this fashion, that is Rin. So why Rin is used in the circuit for a difference? Because to flow of current. So it opposes the flow of current. Summing amplifier. A summing amplifier using an operational amplifier figure shows in figure 1. This circuit produces an output that is the sum of its two input voltages. However, since the operational amplifier is connected in inverting mode, the output voltage is given by V out is equal to minus V1 plus V2, where V1 and V2 are the input voltage. Typically, input and output waveform for the summing amplifier is as shown in the figure 2. The typical amplifier is that of an mixing two input signal to produce an output voltage. So in summing amplifier, two inputs you can give to an inverting amplifier, and non-inverting amplifier is grounded. So n number of input can be given for this. So integrator, if the capacitor is connected as a feedback of an op amp and resistance is connected in this fashion, we will call this as an integrator. So in order to produce a square wave to triangular wave, we will use an op amp as an integrator. Circuit provides the opposite function to that of a differentiator, in that its output is equivalent to the area under the graph of the input function rather than its rate of change. If the input voltage remains constant and is other than 0 volts, the output voltage will ramp up or down according to the priority of the input. The longer the input voltage remains at a particular value, the larger the value of the output voltage. Typical input and output waveform for an integrators are as shown in the figure 2. Notice how the square wave input converted into a wave, that is a triangular shape. Once again, note that the output. So op amp can also be used as a differentiator. You can see the circuit. So if the capacitor is connected across the op amp feedback, we will call that as an integrator, and differentiator if the capacitor is connected to the inverting terminal of an input and a resistance is connected across the feedback resistance of an op amp. The differentiator provides an output voltage that is equivalent to the rate of change of its input. If the input voltage remains constant, the output also remains constant. The faster the input voltage changes, the greater will be the output be. In mathematics, this is equivalent to the differential function. The typical input and output waveforms of the differentiator is as shown in the figure. Notice how the square wave input is converted into a train of short duration pulses at the output. Note also that the output waveform is invert because the sign has been applied to the inverting terminal. So op amp as an amplified circuit or an op amp as a voltage follower. So you can see the voltage follower if resistance is not given across the bypass, so we will call that as an voltage follower. A voltage follower using an operational amplifier is as shown in the figure. This circuit is essential an inverting amplifier in which 100% of the output is fed back to the input. The result is an amplifier that has a voltage gain of 1, which will be unity, a very high input resistance and a very high output resistance. The stage is often referred as an buffer and is used for matching an high impedance circuit to the low impedance circuit. So typically the output waveforms of the voltage follower is as shown in the figure. You can see here input is followed at the output. So that is, it maintains the gain will be the unity so that it stability will be more.